Every time you go to the doctor, a hidden language is at work. A secret code gets assigned to your diagnosis. And it's not just for billing. It's this universal language that helps us track diseases all over the world. Today, we're going to crack the code for one of the most amazing and complex organs in the human body, our skin.
So, here's our game plan. First, we'll get into the skin's secret language itself. Then, we'll dive into some real-world detective work, like figuring out if dermatitis is a reaction or a poisoning. We'll tackle chronic ulcers, then infections and repairs, and we'll wrap it all up with the absolute golden rules for any medical coder.
All right, let's get right into it. The system we're talking about is officially called the International Classification of Diseases, or what everyone just calls ICD-10-CM. The best way to think about it is like a giant library system for every single health condition you can imagine. And we're going straight to Chapter 12, which is all about the skin.
Now, this isn't just some random list of codes they pulled out of a hat. No way. It's a superstructured, totally logical language that healthcare professionals use worldwide. It's what makes sure that a diagnosis made in, say, Texas, can be perfectly understood by a doctor in Tokyo. It's a universal translator for medicine. And this quote right here, this is where you see that coding is so much more than just matching a disease to a number. It's legit detective work. It's not enough to know what the patient has. The coder has to figure out why they have it. That takes some serious precision and judgment.
And just like any good detective, you have to know the scene of the crime. So, time for a super quick anatomy lesson. Our skin isn't just one flat thing. It's made of 3 distinct layers. You've got the epidermis on top, the dermis in the middle, and the subcutaneous tissue at the bottom. Knowing these layers is absolutely crucial because the code you use can completely change depending on how deep a wound or a lesion goes.
Okay, so let's put this into practice with our first major case file. We're going to look at dermatitis, where a really critical distinction all comes down to one single question.
So here's the puzzle. A patient comes in with dermatitis after taking some kind of medication. The coder's first question has to be, was this an adverse effect or was it a poisoning? You might think, what's the difference? Well, in the world of coding, the answer changes everything.
And the difference really just boils down to proper use. An adverse effect is when something bad happens, even though you took the drug exactly as the doctor prescribed. Poisoning, on the other hand, is what we call it when the drug was taken incorrectly. Maybe it was the wrong dose, the wrong drug, you name it.
Okay, now this is cool. Look at how the order of the codes actually flips depending on the situation. If it's an adverse effect, an allergic reaction, the dermatitis is the main event, so it gets coded first. But if it's a poisoning, like an overdose, the poisoning itself is the headline. The dermatitis is just part of the story. The sequence literally tells you what happened.
Let's move on to another really common, but also pretty complicated area to code, chronic ulcers. This is a perfect example of where documentation has to be razor sharp, covering everything from the cause to the exact location and just how bad it is. Now, it might look overwhelming, but coders have a really straightforward 4-step playbook for this. Step 1, figure out the underlying reason for the ulcer. Step 2, code the actual ulcer. Step 3, get super specific about where it is. And step 4, add the stage of severity. Simple as that.
And that first step, the underlying cause, is everything. See, an ulcer doesn't just show up out of nowhere. Is it there because of something like atherosclerosis? Or is it a diabetic ulcer? The code for that root cause always goes first. It's the origin story of the problem.
And the level of detail is just wow. For instance, what happens if a doctor looks at an ulcer but can't tell how deep it is because it's covered by a dead tissue? That's called slough or eschar. Well, believe it or not, there's a code for that. It's called unstageable. It means the full story is hitting, and that piece of information is itself incredibly important.
Okay, let's switch gears and tackle infections like cellulitis and the actual procedures used to fix all these skin problems. And by now, you can probably guess the theme here. The order you put the codes in, the sequencing, is absolutely everything.
It all comes back to this principle of sequencing. The #1 rule is that the first code has to tell you the main reason the patient is even there. Did they come to the hospital for cellulitis? Or did they come in with, say, an open wound that then got infected with cellulitis? The answer to that question changes which code gets top billing. And hey, just to make sure we're all on the same page, what exactly is cellulitis?
Well, it's a pretty common but also potentially serious bacterial infection that gets into the skin and deeper tissues. It usually starts with a simple break in the skin, like a cut, that becomes an open door for bacteria to rush in and cause this big, painful infection.
So, when you have a wound like that, a really common treatment is something called debridement. It sounds kind of technical, but all it really means is clearing out the dead, damaged, or infected gunk so the healthy tissue underneath can finally start to heal. Makes sense, right? But for a coder, the critical detail isn't what was done, but how it was done. And here's that fork in the road. Was the tissue physically cut away with something sharp, like a scalpel? That's excisional debridement. Or was it cleaned out by washing, scrubbing, or irrigating it? That's non-excisional. It might seem like a tiny difference, but in the coding world, these are two completely separate procedures with totally different codes. Okay, we have covered a ton of ground. So let's bring it all home and boil it down to the core principles we've seen again and again. You can think of these as the coder's golden rules for making sense of it all. So, what are these golden rules? Number 1, specificity is your best friend. Be as detailed as humanly possible. Number 2, sequencing tells the story. The order matters. Number 3, always connect the dots between the cause and the effect. And finally, the most important rule of them all, the patient's chart is the ultimate source of truth. In coding, if it wasn't written down, it might as well have never happened. Period. So we've gotten a glimpse of how this incredibly detailed language works right now, but it really makes you wonder about the future, doesn't it? As medicine gets more and more personalized down to our individual DNA, how much more granular are these codes going to get? Could there be a day where there's a code not just for a disease, but for your specific version of it? It just shows you, this secret language of medicine, it's a living thing, and it's being rewritten every single day.